Mario once again with MIA Microflight, and in this video I'm going to be talking a little bit about these miniature power supplies that I've been building for testing and setting up my radio control RC ultralight airplanes, the two cell ultralights that I've been building lately. These are a couple of power supplies that I did. You can see this one right here is one that I showed before. It's just a little box that contains a circuit board, the LM20. Let me look at the board here. LM20. I believe it's the LM2596. Basically, it is this circuit board here. This is a buck DC to DC converter, and it's a nice little board for doing stuff like this. You know, building miniature power supplies. I actually bought these to control some LED strips on one of my other projects. You know, the miniature track that I built for those little cars. You know, you can see that those videos. I have a whole slew of videos on that track. What I did there, you can see what I built and what it looks like, and some of the parts that I built for that track. Some of those were lamps, you know, miniature lamps that I did for the track, and so I bought these so that I can control sections of that track lighting. But I happen to have a couple more of these, so I decided to do this little box. A little while ago I did this because I was getting tired of taking my airplane and bringing that to my test bench where I have the full-scale power supply. You know, the bigger power supply that's full of circuits, and it's kind of a little clutter there. I don't want to remove those circuits because I'm still working on them. So in order not to deal with that, I built this little power supply. And basically what this runs on a 4.2 volts LiPo single cell, and it uses these JST connectors. There are two male connectors as part of this box right here, and basically you know, I can just connect the input supply, which is just a single cell, and I can vary the output using this potentiometer. Hopefully I can do this. Let's see. Why can't I? There we go. Just have to loosen it up. I actually had a regular potentiometer here, a 10K pod. I had a little hole underneath this tag here, but I removed that, and I actually went with an extender to the original multi-turn potentiometer that is part of this board. You can see that potentiometer right there, multi-turn potentiometer. So I basically soldered an extension there, just a brass tubing extension, and then I brought it out this way so that I can have a little more precision on the control. So I can vary, basically. I have an LED, it's sort of my load here, and you can see how I can vary the voltage, and I can adjust the voltage to turn on, you know, the LED is required. These LEDs actually work at, this one works at 3 volts. So let me see if I can, there we go. 2.6, 2.8, 2.9, and you can see it's getting brighter. So basically, that's what this does. And like I said, I designed this for to test my LEDs that I use on my navigation light systems for the miniature aircraft that I built. So this works great. I mean, if you don't, if you're not too critical about controlling the you know, the amperage, because this doesn't have an amp potentiometer to vary the amperage to the load. And that's something that I wanted to have on my second power supply, so I built another one. But basically, this circuit can be retrofitted with a current adjust circuit, and so that's what I'm going to be doing with this particular one that I built. I'm using the same board because I have some of these boards, and not to not to waste these boards. But basically that's what this circuit does. It's got its own readout there. So let me just shut this off. Just disconnect. This is really simple right here. So in this second power supply that I built, I wanted to have I wanted to be portable, number one, and compact, and I wanted it to look like a power supply. So this is what it looks like in CAD, and I'll go over some of these parts right here. It's a power supply that operates via two LiPo 2600 milliamp hour cells, which are these guys right here that I repurposed from an old laptop. So I have plenty of these, and the plate that you see there, this plate right here, is that plate that is right here that I just printed this not too long ago, and so that's going to be sitting right there. I'm just going to hot glue that just so that it doesn't move, and I can, if I need to remove this and replace them, I can do that just by peeling off the hot glue. So that's going to be hot glue there. Basically that's my circuit. That's going to be powered by the two LiPo cells. In order to charge these LiPo cells, because they're going to be inside this case, I made provisions on this back plate to have a circuit, a LiPo charging circuit, which is this little board right here. It uses a micro USB as the input, so you can basically connect this to your computer or whatever and feed a charging current to the LiPos. So this is part of that back plate that you're seeing there. And there's another circuit that I don't have the circuit yet, but I'm waiting for this circuit to be delivered. It's basically just an additional circuit to feed 5 volts as an output, so I can actually charge I can even charge a phone with this, or use it as just an external power supply. Not power supply, but yeah, I guess just power output. So my plate at the back, you can see it says it's 5 volts DC. 2 amp is the max, because that's what this circuit can deliver. 2 amp max to the variable voltage to the output here. We have V in, V out, basically. And so that's basically what I have to feed into this this power supply here, the LiPos. Because these are connected in parallel, it's almost like having just one large cell that has a large capacity. These are, like I said, they run at they're spec'd at 2600 milliamp hour, which boils down to 2.6 amps of capacity, amp hour capacity on each cell. So 2 of these will give me 5.2 amp capacity, which is plenty current for testing things, without having to recharge the batteries often. I could have done this with a transformer, just a regular AC to maybe 5 volt transformer. But I wanted to, like I said, I wanted to keep this very, very compact and portable. And so that's the reason for using these lithium polymer cells as the power delivery to this circuit board. Now, along with this circuit board, like I said, I'm going to have an external circuit that's going to allow this power supply to be adjustable in amperage as well. So that's something that I have to build, and I have to add it onto the circuit here. Not an issue, because there's plenty of room inside here that I can piggyback another board here. But the potentiometers are there already. You can see this one is next to the V for volts, and this one's next to the A on this meter for amperage. This is my output here, which is just a micro. It's microphone plug that I'm going to be using for the output here. This is going to be connected to a plug with a couple alligator clips, and then that'll be my output to my load to connect to the load of whatever I'm testing, whether it's LEDs, motors, whatever. And this is my switch here that allows me to read the input voltage here or the output here. This board right here has that switch built in right here, this switch. So I was saying this board right here has built-in a built-in switch that allows you to read via this readout here, this 7-segment display, this 3-digit 7-segment display. If you press this button right here, it'll read the input voltage. If you press it one more time, it'll read the output voltage, and it's got 2 LEDs to tell you which side it's on or reading. So you have a visual of that. I don't need this right here, so I'm going to bypass that because I'm going to be using this volt amp meter here, which is a lot better than just a voltmeter. So I have to do all the connections, but basically this switch right here, as I was saying, is going to take the place of that button switch on this board right here, so to allow me to read the input and the output voltage. So when this switch is to the left, it's going to read the input voltage coming into that board, and when that's to the right, it's going to read the output voltage. That way I can also monitor the the battery voltage, the supply to this circuit board, because that's basically the input to this board. The 3D printed parts that you see here are done in such a way that I can easily assemble this. That's why I made this as an extrusion here. This part right here that you see here, is that part right there, and it's got provisions for 4 mounting screws, front and back, so I can basically just assemble everything with with these other parts that are part of this box right here. I have the front panel that I already showed, that has the volt amp meter, and these potentiometers and the switch, and the output here, which goes inside the box, like so, attaches with 4 screws. This plate right here that houses the control board, the DC to DC converter, and the batteries, slides into this box. Let me see, where is that side? Slides this way, like that. So I can assemble this real easy after I'm done, making all the connections. And the rear, of course, is done in. I did this in two sections here, so that I can print this facing up this way, and so that my lettering here can come out a lot cleaner than as if this would have been printed upside down. Then you have the letters don't come out as clean, because you have the elephant feet effect of the filament spreading out and kind of closing in on the lettering, because this lettering is rather small. It's about 1/8 of an inch in height. And so I did this in two pieces. After making one, it's a solid piece. You can see what I'm talking about right here. That elephant effect is you can see it here. Some of these letters are not as clean as these right here. You can see how much more defined those letters are right here, because the way I printed, I had to print this like this, with this at the bottom, facing the build plate, so that I can get these tabs here that hold the little circuit boards, the charger for the batteries, and also the other circuit board that's going to have the USB, just a regular USB output board there. And so that's how I had to print this. And basically this part right here is 2 pieces right here. You have that plate, and then that plate, and then this plate. So 2 pieces right here, and they're basically held together by the switch right here, that is designed with with a nice tolerance, so that it doesn't move and it retains both pieces without having to glue them. So that's my switch, my main switch. It's going to turn on everything on and off. So this will go in the back, and basically that's it. That's my power supply, as I just described and showed in this CAD model right here. Great little tool for for working on small circuits, that require low voltages, and low current. Like I said, this board can go up to 2 amps. I believe the specifications for this board right here, it's inside this extrusion right now. This board can handle up to 2 amps maximum without a heatsink. But if you put a heatsink over this chip right here, you can increase the current. I don't plan on using this beyond 1 amp. Even 1 amp is going to be quite generous, for the stuff that I'm doing, because I'm just testing LEDs on little circuits that consume no more than 100 milliamps. Considering each LED consumes 20 milliamps on the average, in a set of LEDs, for the circuits that I'm running, I don't think I'm going to be pulling more than a few hundred milliamps, way under the 2 amp target here that these are designed for. So I'm really good for that. One of the things that really triggered me into doing this, and simply not rely on this little board. This board works okay too for testing, like I showed earlier, but you can see it's kind of just a little flat box, and really doesn't have any gist to it. It's just a box, just covering the circuit board. So what catapulted me into doing this particular circuit project is that I have this device right here that I bought a while back. This is a meter. Actually, no, it's not a meter. It's a tester, and it's got some really nice features here. If you don't have one of these, FYI, it's a tester. I can test. I bought it to test transistors mainly, because I have a bunch of transistors and I wanted to test them, and I wanted to find out, the HFC, whether it's a PNP, NPN, etc. This can also test little chips. I think it can test op amps. It can also test capacitors, resistors. So it's a great little device here. It also has this oscilloscope. So it's got it's got some nice features, but not as intense as a full scale oscilloscope. But it's plenty for doing miniature stuff, and working on small circuits. A great little device. And it has even a function generator. You can set your sine, square, pulse, triangle, ramp waves, and it even provides even a DC output. I think you can go up to maybe 4.2 volts. My battery is not fully charged here, so it's a great little device. So I had this, and so this power supply is kind of in line with this palm size device here. So I wanted to have a little power supply that I can just move around, like I said earlier, and be really portable. So I think this is going to do it for me. I have to build the current adjusting circuit, and once I'm done with that, I'll be completing this project here, and I'll probably do another video just to top it off and just to show this power supply in working mode. So once again, Mario with MIA Microflight, just another video, to capture this stuff, how I do these things and why I do these things. Stay tuned for more. Thanks for watching.